off on chapter 5. We were talking about IOA, and we kind of skipped over IOA obtained by event recording, and we just went straight into the more complicated ones. So we're going to go back and talk about IOA for data obtained by event recording. So last week, we talked about temporal measurement. So temporal, who remembers what temporal is?
Time.
Time, yeah. So where it is in time. So those are going to be your duration. So we learned about total duration. Yes, Erica said at a point in time. So you got your total duration and your mean duration per occurrence. So we learned the formulas for those, and we did our examples. And then we went into the 3 time sampling procedures for IOA, which were the interval by interval, scored interval, and unscored interval. And then we talked about the differences and when you would use each one. So now we can go on to the 4 repeatability measures of IOA. So we are on page 112. And total count. The simplest and crudest indicator of IOA for event recording data compares the total count recorded by each observer per measurement period. So event recording, total count, those are going to be the ones that you use for frequency and stuff like that, where you're just tallying using the clicker. So that's when you would use a total count IOA. It's expressed as a percentage of agreement between the total number of responses recorded by 2 observers, and is calculated by dividing the smaller of the counts by the larger count and multiplying by 100. So our formula is going to be, so we're going to do our smaller count over our larger count.
Should we be seeing what you're writing?
Yes, if you're not, you can scroll or you can zoom out. What was the problem last time that we figured out?
Just scroll up.
Scroll up?
Yeah, or down.
Up or down, okay.
Yeah, down,
Let
I
me
think.
know,
Yeah.
let me
Go
know
down.
if it works out. If not, I don't know what to do. Total count. So this is going to be your simplest way of collecting IOA. And this is when we are, again, using that event recording frequency. We're taking some tallies. Okay, so we were going off of the examples that they gave in Cooper. Okay, so let's see the example here. So for example, suppose that a child care worker in a residential setting recorded that 9-year-old Michael used profane language 10 times during a 30-minute observation period, and that a second observer recorded that Michael swore 9 times during the same period. The total count IOA would be, okay, so first guy is cursing 10 times, second guy is cursing 9 times. All right, so what are we gonna do? What's gonna go on top?
Smaller count?
A small count.
Smaller number.
Larger count.
9?
Yes.
So
Yes.
9 over 10.
Yep, so 9 over 10 curse words. So that's going to give you it's like 0.9, right? So you're gonna times it by 100. And that's going to give us our percent of agreement if we used total count IOA. Sorry, this is hard to do with the mouse.
90%.
Yes, so 90% agreement. So that is pretty high. So you could say, okay, that's pretty reliable. They agree pretty consistently. So great caution must be used in interpreting total count IOA because a high degree of agreement provides no assurance that the two observers recorded the same instances of behavior. So that's important to know, right? It overestimates the extent of actual agreement. Do we write that somewhere? Overestimate
Yep.
extent of actual agreement. So be very careful when using this one. It's always the easiest one. So it's like your safe way out, but it's not very accurate. So if you're trying to be very precise, they would suggest maybe don't use total count. But if you're just trying to be quick, and you're just like, oh my God, let me just check if we're semi on agreement, then you can use total count. Does anybody have any experience with total count IOA or want to add anything to that example?
So that means it's a simple way. It's an easy and simple way, but it's not 100% dependable. You're not sure that they both observers recorded the same instance. What does that mean? Like they might be, one person is recording different thing, the other person probably didn't pay attention to that. That's what they're trying to say, because it says provide no assurance that two observers recorded the same instances of behavior. Okay.
So I guess what it's saying is it's not really telling us like very clearly. Okay, so let's keep reading. For example, the following is one of the countless ways that the data reported by two observers who measured Michael's use of profane language was not represented anywhere close to 90% agreement that they measured the same behaviors. The child care worker could have recorded all 10 occurrences of profane language on her data sheet during the first 15 minutes of the 30-minute observation period, and the second observer recorded just 4 of the total 9 responses reported. I guess because of the time, it's not really accurate. So let's say what if one of them like just guessed, right? Or can somebody else give a better explanation? So like one girl observed 10 all in the first 5 minutes, and then the other girl, she's like, oh, well, I saw 4, and then maybe 9, maybe 5. So maybe because of the, I don't know.
I'm trying to understand this too. I'm trying to understand, Serena. Look, it says it provides no assurance that the two observers recorded the same instances of behavior. So maybe one observer, when he was counting, like phone ring or something happened, you get distracted. You didn't pay attention to that one, which other person did notice. Because of the time limit it has. it has the crudest indicator of IOA or measurement period.
Oh, it's because if we think about it in like interval by interval, one person might have observed it in this interval, but then like you're saying, the other person looked away, so he didn't observe it in this interval.
Right.
And so it's not as precise as if we would go interval by interval and check their data that way. So total count, we're just taking a sum of all the random data they threw at us, but we're not comparing each one. So it's not as accurate because of the point in time where they're collecting the data.
Yeah, what I understood with this definition, look, like if you have a duration or time period of 5 minutes, okay, and you're checking for 5 minutes, you're checking like a summarized data is because it's a total count. So, but the other one has 1 minute, 1 minute, 1 minute, 1 minute, like a 5 different intervals. So you're more precise on that because you're taking each minute. Two people are taking data each minute. So it's less chance that you're going to have a different reading, you're not going to miss as compared to if you're just doing the total count. After 5 minutes, you're putting everything.
Yes. So that's why it's saying that they're not as reliable. It overestimates the extent of actual agreement. For more precise IOA, use trial by trial. Yes, so that's giving you the answer to your question there. So for more precise, use trial by trial. There you go. Hope that helps. But good question, because I'm sure somebody else had the same question. Okay, so next one in the book is going to be mean count per interval IOA. So we already learned about the formula for mean count, right?
Yep.
Over here. So it's the same thing, but this time we're using event recording. So we're going to go to our formula for that one is going to be interval 1 IOA plus interval 2 IOA plus interval 3, and so on and so forth, however many intervals you have. And then you're going to divide by number of intervals equals mean count per IOA. Uh-oh, what happened? Dang, it just disappeared.
You know what? I think somehow my whiteboard, every time I touch it, it's taking your stuff away, but I don't know why, because I can't see what you're doing. But it says I'm co-editing Selena Ramirez whiteboard, but I don't know. I've never had this happen in all my time on Zoom.
You are
So-
collaborating on this whiteboard. So how do I not collaborate?
You can go down because it says, to me, it's also saying the same thing, but I'm not using whiteboard, I'm using notebooks. It's not going to affect you. But there is down in there, it say who can see what you share here, something, you know, like you can stop from other people editing it.
Yeah, for
Okay.
some reason you have
Go to
me
the share. Let me go. I think
Share screen.
No,
Sharing your
in the
screen.
corner it says share. No, it's not.
Advanced sharing options. Who can share? I'm gonna say host only.
Yeah.
Yes,
That's
it should
where
be
you have to go.
Yes.
Yes, that's what you need to do.
Okay, did that help?
It
No,
will
it
help
still
when
says,
you write,
it says, you are co-editing Selena Ramirez's whiteboard. And then when I go to scroll down or do anything, it's just stuck on my, maybe you have to reshare and that'll make a difference.
Yeah, I'm gonna try again. Okay.
I don't know. I've never had it do that before.
Okay, all participants can view, not edit.
There
Yeah.
you go.
Okay, got it. Let's see if this helps.
That should help. I do this for my client all the time.
Oh my gosh, it messed up the whole thing. Oh no, it's okay.
I think you should do that right from the beginning.
Yeah, now you know. You are, now it says I am viewing. So you did it right.
Okay, gotcha. Yeah, this
And I
is
can see it now. For some reason, now I can see it. I couldn't see it last time. Little pieces of it I could see.
okay, so weird. This is our first time using the whiteboard, so I'm like not very tech savvy.
That's all right. We're learning.
Yeah, my client taught me, so now I know.
Okay, that's why we got each other, right?
Yeah, my client. I work with him. He shows me do this, do that, and I'm scared that he's gonna learn everything before me. He shows me that.
Okay. This thing is complicated. Okay, so does it give us an example somewhere for this one?
Oh, mean count.
Oh, 5.2. Okay, so let's go to figure 5.2. 5.2 will be used to illustrate two methods for calculating count per interval IOA, mean count per interval, and exact count per interval. So during a 30-minute observation period, two observers independently tally the number of times each witnessed an instance of a target behavior during each of 6 5-minute intervals. Even though each observer recorded a total of 15 responses within the 30-minute period, their data sheets reveal a high degree of disagreement within the observation period. Although the total count IOA for the entire observation period was 100%, agreement between the two observers within each 5-minute interval ranged from 0 to 100, yielding a mean count per interval IOA of 65.3. Okay, so let's try to calculate the example on 5.2. So on the top, we're going to do interval 1 IOA plus interval 2 plus interval 3 and so on. Okay, so we have to get the IOA for each one. So for IOA, we do smaller over larger, right? So let's go through each interval on figure 5.2. So what is our equation for interval 1?
Over 3.
Yes, so 2 is the smaller one that observer 2 observed over 3. Okay, so let's go to the next one. And that's going to be 3 over 3. Yeah, 3 over 3.
50%.
So for our IOA for this one, it's 67% agreement. Here they agreed 100%. Okay, and then the next one, smaller over larger, is
1 over 2.
50%.
Yeah, 1 over 2, which would give us 50%. Okay, and then interval 4 is 3 and 4, so that one's going to be 3 over 4.
75%.
Yep, 75%. Okay, next one is 0 and 1. So 0 over 1.
That's 0%, yeah.
That gives us 0. And the next one is 4 over 4.
That's 100%.
So for the mean, we got the IOA for each interval. And then they want us to add them all up. Right?
Yeah, and divide by what? 6.
And then divide that by 6.
The number of intervals.
Okay, who wants to add it? Or you guys want me to add it? $67 plus 100 plus 50 plus 75.
417.
100 equals. What
It's
did you get?
417?
What did I do wrong? I got 392.
No. Maybe I made a mistake. You can check it again.
Hold on, let me do it again because I got 392. Did somebody?
Yeah, 392. You're right. Sorry.
392.
Yeah. Divide by 6.
Divided by 6 gives us
65%.
5.3. So the top interval is 65.3. Okay, divided by, oh wait. Mommy, better took my toy away.
So that is not going to be any more division. That's our mean count.
Sorry, they're fighting in the background.
Oh.
Okay, 65.3% is our mean count per interval IOA. So that's it, right?
Yep.
So that's our mean count per interval IOA. So that's this right here. Does anybody have any questions on that or how we got there? Okay, so now it's telling us to use that same example to get the exact count per interval IOA. So now let's go look at the formula for exact count. Okay, so now we're gonna go into exact count. So exact count is the number of intervals of 100% IOA. So let's say number of intervals of 100% IOA. So we want to get even more exact and see how accurate this data is. The number of 100% IOA divided by the number of intervals times 100 will give us our exact count per interval. Okay, so let's go back to our figure 5.2 on page 113. And we're going to use that and get a more accurate representation of that data. So number of intervals with 100% IOA. So how many intervals are there with 100% IOA in that example?
Have 2.
Yes, 2.
Number 2 and number 6.
Yeah.
Yes, perfect. Number 2 and number 6. So it's going to be 2, right? 2 intervals at 100% agreement over number of intervals, which is 6, correct?
Mm-hmm.
And so that will equal 2 divided by 6 equals 33. So it's going to give you 33%. Sorry, guys. Okay, so that's going to give us 33%, right?
Mm-hmm.
Yep.
So 33% agreement. So this one is more accurately representing the actual agreement of the observers. So that's kind of explaining how the total count IOA was not the most accurate representation, because if we just added all of those numbers, if you guys look at the totals, so observer 1 observed the behavior 15 times and observer 2 observed the behavior 15 times. So if we use total count IOA for that situation, it would give us 100% agreement, right? Which is incorrect because they were both observing different behaviors per interval. So that kind of explains it to us a little bit better, why mean count and exact count per interval are a little bit more accurate than if we just did total count. All right. Anybody have any questions or anything on that? So which one do you guys think is the most, they call it the strictest. Which one out of the 3 is the strictest IOA?
Is the exact count. Is the exact count.
Yes. So your exact count is going to be your strictest IOA method. Okay, cool. I like the order that they're going. Okay, so the next one is going to be trial by trial. The agreement between two observers who measure the occurrence or non-occurrence of discrete trial behaviors for which the count of each trial or response opportunity can be 0 or 1 can be calculated by comparing the observers' total counts or by comparing their total counts on a trial by trial basis. Calculating total count IOA for discrete trial data uses the same formula as total count IOA for free operand data. The smaller of the two counts reported by the observers is divided by the larger and multiplied by 100. Okay, so let's see the formula for trial by trial. So that one's going to be the number of trials in agreement over the total number of trials.
So it's the same kind of formula like exact count, you see?
Number of, yeah, trial in agreement okay, number of trials in agreement over the total number of trials, total number of trials times 100 will give us our trial by trial IOA. Okay, is this one giving us an example? Okay, this one doesn't give us a,
It's giving something about the smiling thing, comparing the two
I was just
observers.
looking for a figure, like a,
No, they don't have the chart.
yeah, it's okay. All right, so it says two researchers are going to observe occurrences and non-occurrences of child smiling behavior during 20 trials in which the researchers showed the child a funny picture. The two observers compared data sheets at the end of their session and discovered that they recorded smiles on 14 and 15 trials respectively. The total count IOA for the session is 93. So one person did 14 and one person did 15. So we're going to take our smaller over our larger, right? So one guy said, I saw 14 smiles. Other guy said, I saw 15 smiles. And so if we're getting a total count for them, it's going to give us 93.3%. Is what it's telling us here, which might lead an inexperienced researcher to conclude that the target behavior has been well defined and is being measured with consistency by both observers. Those conclusions, however, would not be warranted. Total count IOA of discrete trial data is subject to the same limitations as total count IOA of free operand data. It tends to overestimate the extent of actual agreement and does not indicate how many responses or which response trials or items posed agreement problems. Comparing the two observers' count of 14 and 15 suggests that they disagreed only on one occurrence or one of the 20 trials. However, it may be possible that any of the 6 trials scored as no smile by the experimenter was scored as a smile trial by the second person. Thus, the total count of 93 vastly overestimates the actual consistency with which the two observers measure the behavior. Okay, so where's our trial by trial example? Or that's it?
That's it.
Oh, so trial by trial and total count is the same?
Trial by trial and total count. This is how I memorized this formula. So trial by trial in total count, not the total count, trial by trial and exact count. They both give you the total agreed number of total agreed interval divided by the total number of interval. So that's how I remember these two formulas are same, exact count and trial by trial. It's just the name change. Exact count had the number of interval, trial by trial have number of trial. But it's exact the same formula.
Okay, so the trial by trial IOA for the two observers smiling data, if calculated with the worst possible degree of agreement from the previous example, that is, if all 6 trials that the primary observer scored as no smile were recorded as smile trials by the second observer, and 5 trials marked by the second observer as no smile were recorded as smile, trial by experimenter would be 45. Okay, so now it's giving us the example. So 9 trials were scored in agreement out of 20. Yes, so she's right. It's the same thing as exact count, except the trial by trial is using, what is the word that they use?
Number of trial.
The number of trials. Okay, so for 6 trials, they observed no smile. And then for 5 trials, they both observed smile. So those were both intervals that were in agreement. So there was 9 total trials scored in agreement. So we're gonna divide it by the number of trials and then times it by 100. Okay, so for that one, it would be 9 over 20. So 9 are in agreement that either yes, we didn't see it together, or no, we didn't see it together, over 20, which is going to give us, what's 9 over 20?
45?
5%.
45, yeah.
Yeah, then you multiply by 100, so you get that.
Times 100.
It's 45%.
45%. So again, it's just emphasizing how trial by trial is going to be more accurate than doing exact count. And those are all 4 methods of repeatability measurements where we are collecting IOA data based off of event recording. Okay, that was crazy. I think I made it harder than in my mind. Does anybody have any questions on those? Or anything to add?
So there's 4 formulas, right, Selena? That's what, there's 4 different formulas, right? We have to know.
Yes, so a total of
1, 2.
Total of 4.
Yes.
Yeah.
I think
for 9 different IOA measures.
Yes.
1,
4
2,
formula. No, 4 formula is only for the event recording one, but there are more. There are more formulas.
Yes, but she's saying like they're the same. So a lot of them are the same. So it just depends on whether you are using temporal. So like if you're using duration or if you're doing time sampling. But the formulas are going to be the same. Just your data collection method is what's going to be changing. Does that make sense?
Repeat that, Selena. So there's, okay, I got to write that down. There's 4.
Okay, so total count and total duration, those are the same formula. Mean count and mean duration per occurrence, those are the same formula.
Right.
And then trial by trial is the same as which one? Which one did we do?
Exact count.
And interval by.
Yeah, trial by trial is the same as exact count, same formula. And then
interval by interval.
Oh, and then interval by interval is grouped with them too, right?
Yes.
Okay, so those are grouped together. And then scored and unscored are those.
Right.
Those are separate. Those are separate.
Those are their own.
Those are for only for those time sampling one.
And how do we follow this? I don't know.
How do you?
Oh my God.
I made a chart. I made a small chart. I don't know if I could send you the picture. I made a chart about
send it, put it in our group chat tomorrow or something.
Do that.
My brain just cannot memorize all this stuff, or I memorize too much and then I can't, what's the word? Like regurgitate it out, or no, actually, that's not the right word. Apply it. Remember, we were talking about that, Selena?
Yeah, the
like,
applied aspect.
But this part here, the IOA, is all just formulas. It's not really, like, you're not really applying, I guess, right? It's more about, it's more about memorizing formulas, so you know.
Yeah, but remember we talked about they might ask you a question like, which one should I use for a time sample? And I want to know the most accurate or most precise of the 3, or for a time sample. And then let's say they give you scored, interval, and then mean duration, total count IOA, and mean count. So you know total count, mean count, and mean duration are for something different. So they're for event recording and temporal duration IOA. So the only one left for a time sample would be the scored interval IOA. So like grouping them like that and not worrying too much about like the math part of it. I don't know if that helps.
Yeah, I've heard the same thing about the IOA. You just need to know what situations to use what equation in. and then eliminate them, eliminate which ones that you don't